there, this is Ananya, and from today onwards, we will be starting off with the series in NumPy. Now, what is NumPy, or rather say, you can also call it numeric Python. NumPy can be pronounced as NumPy, or some like to say it as NumPy also. So it is a Python library that is one of the building blocks in the field of data science. It deals with multi-dimensional arrays, matrices, and a score of mathematical functions that operate on these arrays. In the year 2005, Travis Oliphant incorporated NumArray into the ancestor numeric, which resulted into this awesome fusion called NumPy. And here's the good news. NumPy processes all its operations pretty fast due to its bindings to the C libraries. Now we'll be learning or going through the process of learning NumPy through only exercises because that's the best way you can learn. So you'll have exercises, then examples and maybe some projects too. So stay with me throughout this ride and I hope you understand NumPy and start enjoying it, and maybe you might even select data science as your career. So let's get started. Okay, so for NumPy or Pandas, Matplotlib, whatever that we'll be coming up with, we will have the Anaconda setup and we'll be working on Jupyter Notebook. Now, if you have come to this advanced stage, I'm pretty sure that you know all about setting up Anaconda and you'll have your Jupyter Notebook that you can launch here. So on hitting launch, what you get is basically this homepage, all right? And from here, you can simply select new and a Python 3 notebook. And then your kernel just gets ready, starts running. All right, there you go. And I'm sure you might have worked on Anaconda before or maybe not. There you go, you have kernel starting. So you need to wait for a while. Now, if you are on Anaconda, or maybe any other version, maybe you're not working on Anaconda, no problem at all. You just have to do pip install NumPy or else conda install NumPy, all right? Just like our normal Windows command prompt, you also have the Anaconda command prompt or PowerShell. Let me just show that to you quickly. There you go. You have the PowerShell, the Anaconda prompt. Just run it as an administrator and you can simply work on it. Now let's get to the actual points. You have to import NumPy specifically, and as a universal practice, we give it a pseudonym NP so that we obviously don't have to write NumPy every single time. Now firstly, let's get started off with creating a NumPy array. Now here you do not have the concepts of list, you only have arrays. So you always need to say np.array, all right? And inside that, you have to have your parenthesis, and let's say we are passing a list of items. Let's just keep it sweet and simple now. And 6, all right? Now let's go ahead and print it. Now here's the thing, if you're new to Jupyter, all you have to do is to run it, just simply run it without creating a new row. Just hit Control Enter and you basically get your output. Here, there you go, there's your output. And if you want a new row along with it, just hit Alt Enter. All right, you have your new row to work on. Now you might ask that this looks exactly like a list. Then where's the difference? The difference is when you actually try and print the type of variable A. Let's go ahead and do that. So now what you get is the n-dimensional class, okay? It belongs to the class numpy.n-dimensional array. Now that you have the proof that yes, I'm not working with lists and I'm working with NumPy arrays, let's move ahead. Let's create a complicated array this time. Let me get this down here and I'll modify it here itself. Let's create some multi-dimensional elements inside it. Okay, not just a one-dimensional array, but a multi-dimensional. So we have 1, 2, all right? Give commas between each of them. Now till then, you go ahead and try to guess how is this going to look like. And let's go ahead and print it. So basically everything is universal here. You don't have to keep writing import NumPy in every single row. Okay, and there you go. You have basically 3 rows and 2 columns. All right, so it will be accessed accordingly. And here's one thing, indexing and slicing is exactly the same as you had learned it in lists. So basically there's no difference, and hence I'm not going to be concentrating on that. Since you all already know it, just go ahead and do some exploration by yourself and you all will get it. And I'll put exercises on indexing or slicing in my next lecture, because as I had mentioned, we'll be solving exercises on whatever we learned in the upcoming lectures. All right. So you have theory examples and then practice examples. All right. Now let's go ahead and build a simple list. Okay. Just a moment. What I'm going to do is I'm going to print, or rather say define, a very simple list. Now this list I want to convert it, or rather say typecast it to an n-dimensional NumPy array. What do I do? Very, very simple. Let me give it a new variable, or you can simply overwrite it, doesn't matter. You say np.array, okay, and to that you pass c. Now go ahead and print c new. Control enter. All right, and there you go. You basically, now you can go ahead and print the type of it, then you'll see the difference. So you don't have the commas here, right? You can obviously understand. Now how do we, remember we were saying it has 3 rows and 2 columns. How do we get the shape of it? You can actually call this a shape. So how do we get to do that? You say print np dot shape. Now there are various methods that you have to explore by yourself. All right, this is not just a one-day job and there you go, I'm done. There's a lot to be learned and explored. There you go, you get a tuple that is returned that says rows comma columns, that is 3 rows and 2 columns. All right, now let's move ahead. I hope you're getting it. It's not very difficult. Now what would you do if you want, let's say, the first array that we had taken, and I want to make each element of the array a multiple of 10. How would you do that if this was a list in simple Python? You would take it inside a for loop and do all of that. But just see how simple it is. You don't have to apply any for loop. You just say a is equal to a into 10. That's all you do. You save so much of time, right? And there you go. Let's just run this. Okay, there's an error. Where did I go wrong? Oh, I'm so sorry. I put the multiplication after the equal to. My bad. Now let's run that again. And there you go. You have 10 to 60, all multiples of 10. Pretty easy, right? Now next, remember the range function we had in normal Python? How do you think you can create ranges in NumPy? Again, pretty simple. Let's say you want numbers from 5 to 50. All right. Now, I'm just doing something. See how you can actually figure out what happens from that. So I say np.arrange. Okay, keep note of this. It's ARANGE. And you pass 5, 50. Now let's see what happens. Again, print A. See, so what did you get? You got numbers from 5 to 49, similar to the range which excludes our end element. And by default, the step count is 1, same like range. Now, what if I wanted a different step count? Let's say I want 5, or let's say 6, all right? Now, let's run that. There you go. For a difference of 6, it goes up to 47. 47 plus 6 obviously will exceed 50. There's no doubt about that. So that's how you go about it. And now, let's say, I'm going to show y'all a function. Try and guess what's actually happening, rather than me telling that to y'all. So you have a variable np.inspace, okay, and to that I pass parameters 1 to 10. Okay, that's all I'm doing. Now, based on the output, try and guess what's happening. There you go. What do you think is actually happening out here? So what happens is, if you guessed it correctly, here's the answer. It goes and takes the upper and lower bound, includes them in the range, and gives as many random numbers as possible between 1 to 10, including 1 and 10 also. Now, if just be careful as to what I mentioned, as many random numbers. Now, as many by default is 50. It gives 50 values by default, not more than that, not less than that. Now, what if I want to specify as to how many random numbers I want? Let's say 7. Now, if I run this, there you go. You just have 7 numbers given to you, right? So this is how you can get random numbers between a certain range, or get 50 random numbers for yourself, including the upper and lower bounds. All right, now indexing and slicing, as I had mentioned, it's the same. That's your task to find out. And here's another thing that I want you all to do. I want you all to go search the net and figure out what reshape does. Okay, the function name is reshape. I want you all to go and figure that out. What does it do? How can you implement it? Pretty simple, okay? Just a few tasks that you need to do by yourself. Okay? Now let's end off today's day with a little bit of a very, very simple array creation. That is, what if you want an array of only ones or an array of only zeros? So what do? Here is the code. Pretty simple. np.ones. You say np.ones and you pass the number of rows and columns of ones that you want. And here's the new thing, the data type. By default, it remains as float. Now, if you want only int, you can say that, no problem at all. Now, let's go ahead and run that. And there you have 2 rows and 3 columns of ones. Let's say I want zeros. Okay. So this is basically I hope this is the correct spelling that we use. Let me just run it and check. Okay, that's not the spelling that we use. I was right and I was wrong at the same moment. Okay, so again, 2 rows of zeros, 3 columns of zeros, right? All right, so this is basically it. This was enough to get you all started. There's a lot for you all to absorb, and let's get ready for next lecture's exercises. All the best, and I'll see you all soon.